Okay, ready? I will mirror this over. So you can see that sometimes all these things appearing can be very annoying. So you understand the flow. I mean, you can turn it off. Under analyze, show disconnect, uncheck. All right, now it's gone. Okay, so from here, I want to mirror. Okay, make sure everything's selected. Come to your view. Oops. Fitting, don't care. See the fitting? Don't select the fitting. Fitting doesn't have any effect. Important is the pipes. Okay. Only up to the pipe. Mirror, pick axis, over. Okay. Then first is here. Now the part not there, don't worry. The moment you drag them and join, the fitting will automatically created. So save your time. This one delete. Add the plug. So where can I get the plug? Let's say if I get from here, right click, create similar, auto size up. Don't worry. So it's slightly bigger than the other one. See, slightly bigger than this because the pipe size will increase. All right. Okay. Any more is to clean up this area. Remember, don't be just say, hey, nothing happens. No. Go back to my plan. Align function AL. Align back to here. The first thing, go back to your section BB. Get this guy joined up nicely. Remember, make sure it's point, not just endpoint. See, don't work that way. Point nodes. Then everything should be okay. Okay. So currently, as I mentioned just now, all your connection here for the sanitary is done. The last part for the sanitary is actually this one. Now in this one here, in order to so-called the underneath the pipe share the same throughout, you guys must make sure that the alignment is there. Now that day I draw here is temporarily, how to say too far out. Same thing for this also. This is also too far out. Why I say too far out? Because you assume that this is the cubicle, and here normally is the walkway. That means your cubicle, you turn the L shape here, right? See now. So L shape here, unless some L shape here, there's a T lah. This guy can be blocked there. Because this side cannot be in the walkway. And depends on the depth here. If my door here, there's a swing outside. All right, some toilet, their door is always swing outside. By right, it should swing inside. So it depends on how you want to design the WC, the cubicle itself. So to avoid that, I will say that this one can be roughly placed in the center if the partition is in the center for the cubicle. Now this one can be dragged closer because due to whether the door is opening outside or inside. This one because we don't have any archi detail or unless the architect tell me, M&E company or contractor, you guys provide me the cubicle that's specified in the archi. Then it depends on the archi file. Did it show the swing opening inward or outward? So you guys got to take note on this. All right, it might be not your job, but depends on the design. It can be sometime in concrete, some is just wood, so it depends. So anyway, to shift it, simple, select your floor trap, arrow left, move it. But you see when I move it, they partially adjusted. You want that? No, undo. Okay, what happens if I select this pipe? I move. See, the whole thing move. Notice that? Ah, take note, ah. Okay, now the pipes. Normally, if you select this, it should move lah. But because here got too many shape here. If this one straight line is supposed to move, but this is tied out to this part. So if you select here, both move at the same time. Yeah. Okay, next type is this two. Now this two is also too far away out. See, when you pee here, definitely your leg will step here. In long term, this guy will be flattened already. So I don't want. So this one should be moved somewhere in the center, which is should be closest to the wall here. Somewhere here first. In between, don't let people step on it. It should be somewhere here. Yeah, closer to here. Whether left on that side or this side, just adjust a bit lah. Unless you know have a reference plane in the center that you align lor. But I think you can use this to align, right? This somewhere in the center, right? You want to align, just go align. Anything for you to snap a center? Seems that no. Nothing to center lah. If no center, then doesn't matter lah. As long as it's roughly there, it will do. But these two must be in line. See, so I'm going to use align reference, align this. Okay, like that. Yeah, all good. So here to here. Now, all good. Ready? Go back to your section AA. Now, in order to see this pipe, but you can see currently they are all being overlapped, being blocked. You can't see. You can't see. It's difficult for you to draw also. So what I'm going to show you is you select the current pipe first. What you see from here. Press Control key, select some more. Yeah. Maybe this one I also want to highlight because maybe it's too close. Yeah. At the same time, this one also. At the same time, which one? This one here, I will say never mind, you can leave it. Temporarily hidden means what? Sunglass. Select the sunglass, hide element. You can see? All right, but here that doesn't matter lah because your drawing is still on your section ma. But remember lah, this section, what you're seeing in your plan is this line here. But you need to add something here, it might not connect. So be careful. Okay, this is what I'm going to show you now. Go back to your section AA. You might say, hey Bernard, this one looks okay. Can I copy this and paste here? You will give it a try. You can, but hopefully it can snap. But if it doesn't, meaning what? You check on your plan. Are they aligned or are you drawing at this plane here? Because your section AA is actually this line. But you can see this guy is inside. So be careful. All right. Okay. Next thing is the piping. Because your pipe to draw from here along this way, you can't draw on your section AA. Because if you draw your pipe from here, it's as good as you are drawing on this plan. Or this plane, sorry. So you need to understand all this view. They're easy for you to do modeling. Okay, so I'm going to do a copy and paste here. So I'm going to go to the section AA first. Select maybe, oops, these two. Then how? Copy. Window. Endpoint. Then try to snap endpoint here. Okay. See or not? So this review does telling you, hey, this one looks okay, but you can see missing line. Some people don't know, Stay at this view. Sure, how come cannot snap? You ask me lah. You tell me lah. It's already far apart. So in order to get it back, go back to your plan. Right here. Do the alignment. So align this line. See now the dot. Center of this. Now it looks okay. So always when you do your MEP, some them might say difficult to learn because you tend to model and looking at one view. But for MEP, you must have at least two views. What happened to my throat? Excuse me. Same application for archi and structure. You design something, you must check, make sure the view, they are all connected properly. So it looks okay for me. Go back to my section AA. See, just need to join this only and you are good. Now you're done already. Okay. The next step, not just to copy this to this, is to draw the actual pipe connected to there. All right. So pipe connected to there, you can actually draw from here. Now, this is a sloping pipe, correct? So you can actually draw the sloping percent if you want. All right, if you don't want, you draw a straight pipe, is still okay, seriously. Because this pipe is big enough, it's 100 mm in diameter. So basically up to you. You want to try sloping? You might say, sure, in this the case, where should I start the sloping percent? Now, in your plan, you got to track exactly the center here, right? So I will say that from this edge here, snap to here. So from here, this is downward now, slope downward to this. Okay, but to what I feel is this way up is easier. Why? Because here you got nowhere to stop, where to snap. I'd rather draw outside here, I align inside. That easier that way. If you want to have a sloping one. So if you draw a sloping percent, I will select this pipe. Right click. Create similar. See now, this one is slope up. Draw from here, slope down. So slope up, percent 1.05. Randomly here, center. This way all the way up. Longer is okay, no worries. Okay, like this. So you look at the actual view here, see it's sloping. See that? It's sloping, slanting. Slanting. Don't eager to connect first. At your plan, you do the, excuse me, what happened to my throat? Alignment, center. See that? You align. So align. This joint also nicely shown. See? Look at it. Look at the joint. Now it's time to get them connected. Now, so connected, you got to go to your section AA here. So draw, connect here. So connecting point, protract, right click, draw pipes. So straight first, then vertically down, no sloping, remember. This one sloping also wrong, but it should be off slope, off sloping, I forget, so escape first. This is wrong. Point, right click at the grid, connecting point, draw pipe, it should be slope off. So you draw a straight pipe. See, straight pipe. Then vertically down, touches. Okay, this is correct now. Now, whether this is how far or you want them to be back to back, then you select this and you move lah. Okay, like this. So this one okay, this one delete lah. Because this person is still fixed, so internally the system still auto adjust themselves, so still all right. As for here, take away the opening, it connect nicely. All right, so same thing applies here. Don't copy the same old thing because this slope and this slope is different. So what I want you to copy is only this. So later you extend the auto connect. So from here, you can copy point here. Okay, it might not show connect lah, definitely, because the view for copying, there's no relationship yet. So you simply fidget a bit, make sure it's point and vertical. When it snap, then it's okay. Followed by the last piece, vertically down, touches this line. Everything done nicely. So all these are talking about accuracy and the snapping. So how you arrange your section view, all this is important also. Yeah. So more or less, our sanitary is done. Only need to add some final pieces. You see not? All our pipes, certain area we can have clear space for choking like these two. How about our main pipe? We also need that. So another place to add the clearance for the choke pipe for every floor is around at this pipe. So we can only add this at the section and modify then from the plan. Okay, so ready? I go to the section AA first, which is you can see from here. Now the clear component for the choke pipe, is actually a fitting, because here they don't have a proper piping component. So they will, based on what they have here utilize it . In Singapore, actually, we don't have a separate component. They just add a fitting at the pipe itself. Because the pipe, when there's a bend, there's a fitting, there's an opening cap to open up. Every floor we have one. But here for this special case, we don't have that. So we got to add a fitting. So I can go to system, insert a pipe fitting. And this pipe fitting basically is quite big size in the sense that the design quite huge. So you go back to pipe, Singapore pipes, fitting, PVC, SCH40, the model, socket type, DWV. Then you scroll down to look for, it's called this one here, M-way combination with 8 band. This one of the design component name so we just leave it as a name. This one is a double, means this guy got a double head come out. You see when you select it, you can see from here. You select this guy like your double way joint. Yeah, so what you want is this, because the extension here is longer. And it's not kind of curved, it's just a straight one. Okay. This is where you can actually create a sub pipe from there if you want. All right. The air vent, as I said, air vent. But meantime, we just take this first. So open. Then we insert here. Insert that time, you try to set what is the height. Okay, here, if you don't have, just insert first. And remember to flip, not the other way around. It's this way around. Yeah. Then what is the height? Give you around 1,002. You cannot be too low. 1.2 should be okay. So it's here and it's pointing inside, which is what we don't want. Go back to your plan. 3D, you can see, so this guy got to be floating or rotate outside. So meaning should be on the other side here. So come to your plan. You see your orientation circle, the round is here. But I'm going to see which one you are turning lah. This one should be rotating this lah. So I pick this. Difficult lah to see. See. Ooh, wrong way. This one. This one. Nah, it's outside now. See now, it's exactly now at your opening on the structural wall. So in other words, I've got to draw the pipe exactly some extension outside the wall like that. So here might not see clearly. You may want to take a look at the 3D itself, which is here. So yeah, this is how much you want to protrude out lah. Some spacing, see. And from here, or you want to closest to the wall also can drag shorter lah. All right. See now adjusted already, the whole thing affected. My goodness, never like that. Careful, because of the view itself. So careful, because when you snap, it could be select other components. So plan is not a good idea. It should be at your elevation. So elevation actually is section BB. All right, which is, you don't see it, go back to your plan to align this position. So align where? This pipe to this. See now? You can see clearly. So Revit here, when you do piping, the tricks here is how good are you designing this? Oh, sorry. I mean, set up the correct view to get your model done. So all this is how your tips and tricks, whether you're doing MVP, Archi, and structure, is the same. Always think of a way to let you model. That's important. Okay, now I'm going to place the plug. So plug system, pipe fitting, look for now M plug PVC, and you cover it. Done already. So now this sanitary system for this level, I will say that is completed. Has completed. So if you are doing other level, you can just simply copy and paste. And then of course, depends on the other level, what's the requirement. If the designs are different, you copy something similar, add in and just do remodel again. But it saves you a lot of time. No need to every time to redraw again. It's just that with design on other floor, you need to take note is the depth. Because first story, we got no range limit. It's on the ground, but you do on the second and third, you need to know what is our ceiling. You cannot say, hey, this one draw below the ceiling. People can see what's there. Or this guy's knocking at the ceiling. Okay, so you need to take note. Don't just say follow blindly. All right. Do with a heart, understand. Then to show your, the skill set you harness. That's more important. Okay, so this is done really. Questions?
Teacher?
Yes.
Can you show me again the place of the pipe fitting in the library?
This one?
Yeah, that's one.
Okay, this one is under, if you go to insert, load family, is actually here. You can see all the pipe fitting, like just now, who asked me? Zara asked me also, right? Where is Devin?
Oh, no.
Okay. Okay, no, just not earlier. I think someone asked me how to insert the S strap, right? The P trap. It's exactly also the same location. All the fitting is from here. Yeah. So okay, no worries.
Okay.
It's all from here. Yeah, so it's a very long folder location. See,
Yes, sir.
see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. My goodness, 11 subfolder. It's damn scary. Okay.
Okay, sir.
Mm.
Thank you, sir.
Okay, no problem. So you download already. I mean, you insert in, then you can drag and drop lah. Easy that way. Yeah. All good. Don't worry. All these you go through the video. It's all recorded. Yeah, you can actually reference. All right. Okay. Any other questions? What these guys are doing? If you are doing, then I will pause the video first. Then no need to record them blank slot. You see. Yeah. Oops. Lucky lah that the video did show the initial one. So just drag. Come on. Make sure that what you see the O step is this point, not end point, not others. So you see point, you let go. It should be create the reducer for you.
Okay, Ken. Thank you.
One more, last one, which is on top here. See this part?
Yeah.
This pipe and this sink is not connected. So I need to go to my plan view, adjust it to here, my view, so that my section BB here can see. So align, AL, select my sink, align this section over. Now, you look closer. See, it's not connected. So when always remember you guys mirror pipe, the connecting for the top and bottom, always must fine tune them. So in this case, we just need to flex a bit to make sure that the points show you point. This time around, you show me vertical at the same time. So let go. Once they're connected, it should be see the full pipe size, not just like a partial ghostly kind of image. Okay, done already.
Okay, Ken. Thank you.
Okay. Okay, now I'm going to set this viewer back to here. So I'm going to align back. Okay, everyone ready? The thing here is only sanitary. Normally, I like to use what they call the generate layout or generate the model out, because this guy got so many percent and so many component connecting one another. It's easier to let the system create. All right, because all these are gravity and easier to design lah. Things that with pressure, for instance, your cold water piping. All right, the supply, we don't need to have any slope. It's always horizontal, vertical. Why? Because they are pressure. So pressure pipe, of course, depends on the material use. Because different material, some material are good, some material are bad. Sorry, let me rephrase. I was not say bad. It's where you apply. Some, if you, let's say the main supply pipe, if I use copper, copper actually is the best for delivery so-called clean water. Why? The inner pipe, it won't have any so-called dirt accumulated. Seriously. But one thing is copper very flimsy. You bend a few times, what happens? It breaks. So people will say, okay, maybe certain places got earthquake lah, or maybe some crush adjustment lah. Then that's not a good idea to lay a copper pipe. They might get something stronger. You see? So a lot of piping, let's say water transfer, the main supply piping, because it's pressure. Bigger the pipe, pressure drop. Smaller the pipe, pressure increase. So as an engineer, they need to calculate what is the pump size to require to supply or pump the water to the rest of the usage. Now, normally, let's say we talk about HDB. HDB water pipe incoming supplier, let's say we don't have extra pumps or booster kind of thing to push the water pressure go up, so they can supply up to 3 to 4 story based on the HDB lah, the water incoming lah. Of course, if we talk about high rise, right, of course the water cannot go up already ma. So they need to have a pump to pump this water to the last level, and you have a storage tank. So based on storage tank, you let the water natural flow, means what? They have certain pressure, but sometimes not strong enough. So they need to have a kind of booster pump to pump up the water. So you can see that when you talk about all this, below there's a surface up to certain floor, top up to certain floor. So it's open this way direction to supply. Especially when I show you that previously why I changed the color to magenta, right? Or to that kind of red color. You can see the color code for that. Let's go and take a look again. Is it downloaded here? Oh, it's not here. My BCA mechanical MEP under MEP lab. How come not here? Submission. You see this essential? That's not what I mentioned. You see from here, all the way at the bottom. Remember the color code? See, this is for aircon. Last week we do is the, which one? Sanitary, right? Now you see your cold water. You can see now, booster pipe. That's why sometimes we're on top, some roof, they have some pump. Is to draw the water from the tank. So they set certain time frame. Let's say the water in the tank lower, right? Then trigger to pump. Then people complain, hey, usage pressure drop. The booster pipe will come in. So always there's a so-called like backup lah. So you can see gravity, like natural flow lah. You know piping ma. One high, one low, the auto flow lah. That's called gravity lah. So this for transfer pipe lah. Means one tank to another tank. That's called transfer water. So all these, they have different color. So that when you install, you understand which is which. Easy to design. Okay, just that now we are not doing that detail. So we only say, okay, we want domestic cold water. So we might take as transfer, which is a 230. Yeah. Or most likely could be a booster pipe, right? That is 214 lah. Okay. Questions? Transfer means what? From HDB, you transfer this to the tank. Then gravity one is your natural one. Then maybe booster come in, kicks in, it override the other one. Pop. So like a valve trigger lah. Normally they will have one automatic pipe trigger lah. So, okay, so these are the colors that's here lah. Then you see new water. Our reservoir water are running low. What happened? Your side, you use to recycle new water, right? It pump into your reservoir lah. So all these piping system also have lah. See, if not Singapore summertime, the reservoir drop, right? What happened? Dry ma. Then people like to bathe more quite often, drink a lot of water lah. Yeah. Then the level will drop. Then new water will be introduced into your reservoir. Okay. Yeah. Take note. So since you understand this, that's easier for us to do our thing. Okay, now come back to here. Okay, good. So based on what you are designing, as I said, I prefer manual because here there's no so-called where's my base lah, let this guy auto generate, unless you are doing as a full model, then you know, hey, where is my pump? So normally the pump for the premises is somewhere near maybe your power station or could be somewhere outside, which is nearer to the main supply pipe from HDB lah, easier to manage ma. All right, so then again depends on, it might be a main one branch to a few, but of course the main one is where the water supply intake lah. So there's always a meter reading ma. For total, and individual supply to your household is also a meter because that's your usage. If not, how they charge you money. Correct or not? Yeah. So from here, supply to the building, diameter is 50 mm pipe. Okay, to the building only, not into your household, to your shower tap, haven't yet. So from what you see here, you go to sketch. So go to system. Now the pipe here, as I said, the material must be this PVC. No, it's metal. Metal means standard. If you want to be precise, you can create like carbon steel lah, copper pipe lah, or galvanized steels lah, whatever. Okay, but here meantime, they doesn't allow you to create first, unless you want to say a edit type. I want to create maybe using what galvanized steel. Okay, although now default is not loaded or don't have, you need to build. Let's say I'll use what material I have. So before I create a new one, let's take a look from here. Routing references, edit. This is where you can see, oops, it could be on my other screen. Hold on. Yeah, on this screen. You see that this is now currently the component that we have. We have copper A, copper B, could be different hardness lah, thickness lah. Then you can see here is iron ductile. You see that polyvinyl chloride lah. Rigid means hard lah, right? Not flexible type This has got stainless steel lah, got carbon steel. See, there's no galvanized and some others. So maybe most likely in US, these are the piping material they use. But here in Singapore, we have others because you need to know that piping for water, piping for wastewater, piping for your fire sprinkle, all these are different. All right, because fire sprinkler should be carbon steel, if not wrong. All right. Then stainless steel can be anywhere, but of course, stainless steel is costly lah. You see, of course, for fresh water in household, it should be copper. But copper, in long run, the external view not nice because you kind of got algae or mold will grow, and you need to do some painting. But the internal, the dirt accumulation is lower compared to any other steel. I try myself, I can see my old house, I use what? Stainless steel. Wow, when I take out the pipe inside, terrible. A lot of dirt accumulated, then the pressure drop. The copper one, clean one, but outside is still very ugly. You must always do painting to furnish it so it looks presentable. So sometimes, which is more important? Your health, right? So you drink water, come up from that must be cleaner, you see? So take note of all these things. Okay, so maybe I'll use all same called copper lah, but whether A, B, C or not the size, I don't know, because this is the US catalog. Unless we have a proper catalog to address all this naming, I will do a rename. That is easier that way. So maybe I'll take as copper A lah. If copper A, then of course you pick okay. The rest are just the size lah, so no worries. So copper A, I'll just say duplicate lor. Leave the original untouched because system you can use this for others. So you can use this for your domestic cold water. So in short is what? Domestic cold water, DCW. Then you can put dash, let's say copper. But currently I just use as A lah. Unless I have a proper name, I will change lah. So in this case, I'll use all the same. All right. Make your task easier. Okay. Now I pick okay. Then I draw one here first. When you draw your pipe, as I said, default, make sure know what is the usage. See, sanitary, my goodness. It's not sanitary, it should be what? cold water, always remember, if sanitary later become green color, cold water is blue color. Because this part here, rabbit don't understand what you want. So we must know what we want. So later you guys do your model. How come this guy doesn't show me the correct one? So take note of that. Then there's no sloping. Now the default pipe size supply from the pump is 50 mm, 2 inch. Okay, 50 mm. So you just simply draw randomly anywhere here first. Don't worry. Somewhere from here, draw one pipe upward to the next level like this. Because you're going to supply to other floor, so you can see the color should be in blue. You look at the 3D. If this guy doesn't show blue, then you should know how to apply the color, right? What's the color code? Just now. So apply a filter, adjust to this. Okay. So of course here when you sketch from the section A, you see this guy it clash with my sanitary pipe. So you go to your plan, which is your first story. You can see from here. Now, see that? Select your pipe, move towards the right because pipe is pressure. When the water supply comes or the motor runs, you'll find that there's a vibration always. So all these steel pipe, they must have a bracket to hold the pipe near the wall. So in other words, you could move them away and somewhere here. All right. So the bracket can be up a bit. I mean this pipe and somewhere here. Not so close. This bit too close already. Normally there's a space, we call the holder lah, unless you have a holder size. Currently I don't have, so I just assume that the space is there. Unless we need to source the holder lah, then we go and create lah. Revit currently don't have lah. So next time we do what do you call that? Construction work for M&E. That means you need to draw detail lah. What is the gap distance between hold it? Normally it's near the fitting corner. Then if it's too long, this pipe might sag down. So they must in between support. So all these things will later part lah. Okay. Now is more on conceptual. It means what? Clear my clashes. What is the space required for my piping? That's more important. So looks okay for me. When it's done, your view look like this lah. See? And by right on your plan, it should be a pipe connecting straight this way lah. But because I don't know where is the direction, so I don't care lah. You see? But if you want to draw from here straight, also can. All right. Why I can't draw somewhere here? Because you look at the section. Sorry, section is BB. Look at the sorry, it's the AA. You see here, there's a wedge. See this shape here? So if you want, there should be a pipe not touching here. See, if you don't clash on this, right, it should be somewhere lower than this pipe. So if you want to draw, can, but you don't know what is the height. So you may want to measure from here. Let's say estimate here to here. See the depth? It's around 300. I think 300 should be okay, but it's very close. 325 should be good. The pipe, the depth. So minus 325. So 325 if you want. And the plan, you draw the pipe. So pipe, copper A, all right, cold water. Remember it's 50. Here, I don't care. Any offset? Top elevation? Nope. Reference level, this one should be what? Minus 325. It's on the bottom. Now you draw one pipe across. Okay, so maybe from here, the tracking. All right, I don't know elsewhere got taller or not. If not, I just draw one piece across like that. A sign across. Yeah. Remember there's a column there. Don't clash at the column. If not, nightmare. Then your pipe could be like a snake turn there already. Yeah. So carefully Yeah, see the join? They automatically create for you. So from my point of view, you've got to check on here. Like this guy, you're still able to move a bit to your right. If not, you can see it quite close to the column. Okay, I think this is good. Check your plan again. See, it's away. Then for 3D, which part is not connected or not required is this bottom side. Delete away. This one, you minus it. So it's a T joint because you supply both. Okay, question. So at least in the 3D, you get your supply part there. So there's no clash at all. Have or not? Ooh, see, no clash at all. See? Okay. Quite interesting, eh? Nice, eh? Okay, so we have what we want now is to connect internally. All good before I continue? Okay, so now let's go to our section AA. Yes. Now, the supply into the household now, the branching out is 25 mm. Then when it 25 mm, it distribute to your WC, distribute to your basing, distribute to the water heater, whether it's a water heater, and issue to your shower. Now, all these will depends on the tap connection. Normally, due to the pressure, the connection is around 15 diameter. Yeah, but here you need to check all your connecting point. See, 25, 25, and 20. This guy is using 20. Yeah, good. This is 20. This is both. You see, this guy got oops, 25, 25. It's impossible 25 lah. Is the outlet is 25, but the pipe from the heater is only 15, 15. So there's an adapter needed. Okay. I realized one thing. What's wrong here? Can you tell me? There's an error here. Look at the urinal. I realize it. You select the urinal. What is the urinal size? 25. Correct. What is the pipe here? 20. Notice that or not? The library provided by Autodesk Sabo. The programmer forget to change the data set. So if you get this style of urinal, your QS will butter you. Hey, you do your model, you never check one. So how? It says 25, right? So this one need to be changed as 25. How to change? Edit family. If you guys follow me, of course, all are wrong. I just insert first. But when you model, you need to double check. See, 20, here says 25. So I need to edit. You open up the family. Select the water supply, the radius. You pick this. You see the value here. You scroll down. See, it says 10. Now 10, I can't change, but I link to a value called parameter. You expand it. It's called cold water radius. Now, where can I look for this cold water radius? Okay, where can I find this parameter or the label here? It's under this one called family type. Open up family type. You notice that the parameter here look for cold water radius, which is now here, this one. See that? You see? So this one I got to change. It's 25, right? So it's what? 12.5 radius ma. Then this one you can see because the diameter is based in the formula, so it automatically will update 25. That's it, you are good. Now you click apply, okay. You select one more time. See now 12.5 radius. So everything all okay, good. Just look into your project. And they ask you, remember, override the existing version and its parameter. If you are not sure, always look for the long file name or the long description. I mentioned that a lot of times, so remember that. Select this, it will be updated. Now you select one more time. It should be 20 again. You must be joking. Did I make mistake? No, right? Hey, sorry. I thought I done that. See 12.5 correct, right? Cold water radius. That's sanitary diameter. Cold water radius to how come doesn't update? Hey, correct 25 Funny Load to project. No change. Still 20 What a joke. Yeah, see, NASA there. Look at it. Okay, no choice. We got to save a copy and copy and paste. That means this one. Overwrite. All right, save it. All right, into your plumbing, into anywhere if you want. Yep, so I save it here. Okay, after that, I try to override this when I load in. So where to load in our project, right? Window Explorer, go to your MEP project. No, BCA, your students. October, your class, mechanical here, plumbing. See, it's here. Select this, drag and drop. Hopefully it does override. If you don't override that, I don't know. Okay. Still the same. Okay. Select two of them. Do a switch. Where is our urinal? Plumbing fixture. Plumbing fixture here. Wall M urinal. Okay. I know why already. It's the naming doesn't change. Okay, understand. You see, this got two names. It's the naming doesn't change. Okay, understood. I was thinking how come doesn't change. So select back again, you add it. So the naming part is actually under here, which is you can see this? You put here 25, you select 25 lah. See, both value are the same. See, 20 is 25. 25 is the other way around. So that means I got to change the value here. 20, make sure here this is 20. So here this is 10. Apply. This data will attach to this. And this one here, 25. Here must show 12.5. There you apply. So now you see that I switch back to 20, they auto show me 20. Switch it back to 25, it show me 25. See, if okay now, apply, okay, load into project, override again. I think now should be perfectly all right. Okay. Now 25. Cool. Okay, you might spend some time there, but at least you understand how you make changes. Not sure, please refer to the video. Okay. Don't blindly and give me the wrong one. Two is also to be aware of what you are modeling. Okay. Now let's do our model. Go back to our section. So this height here, if inside the wall, no need to be set very high. So simply go to system, pipe. I'll choose copper A. But the pipe size now, the bigger size is 25. So I'm going to change this to 25. Although here I change 25, but you notice that the moment you snap from here, center, it automatically switches back to 50 because it get the data from the existing pipe. So you still go to change back again. So if you know the tricks here, it means don't change the pipe size first. When it connected, then you start to switch. Draw across one to here, extend. Why? Because this water pipe here later going to supply to your water heater. And then your water heater will come out with the smaller one. But individually, one-on-one, this is 50, this is 25. Okay, height, of course, you can set a proper height lah. This one 16 something. Let's say give you around 16 lah. More value lah, easier to adjust. Okay, nicer that way. After that, you can draw your piping now. All right, so from here, point, right click, draw pipes. Make sure it's not PVC, double check always. Okay, look for domestic cold water, copper. Then, see, it doesn't track the position, so don't worry, just draw first. Okay, how to align the point exactly here to the connection. Zoom in, use the alignment tools. So AL, where's the reference? Here. All right, click once. Hey, reference lah, lama. Reference RP AL align when you're snapping it. Why ask me to place pipe? Excuse me. AL is align. It's a dot. Then you align where? See? After that, select the pipe, right click, draw pipe. Double check, make sure it's correct. You join here. It looks like that. Okay, so 3D, it become like this. Okay. Now, logically, in Singapore, every water pipe outlet connection, you must have a valve. Okay, see this American method. How am I going to insert a valve? No, right? Because everything is internal. So in Singapore toilet, everywhere, you will see that the WC below, normally is at the bottom left. There's always an outlet. You have a check valve, or they call it gate valve. Then there's a flex pipe connect to the bottom of the WC, where's the water inlet. So as a stopper, right? Remember? That's the one. Which is here we don't have. So I'm not going to add any pipe. I mean, not add any valve there because it's enclosed inside the building. Right? I mean the cavity here, you see, in your plan here, there's a cavity here, How am I going to add a valve and start to adjust? No way, what? Okay, so in certain detail, if it's not required, then no need to do. Those that need to be see visible one, then yes. But of course, in drawer practice, all this must highlight to the main con. Okay, or highlight to Aki. Why you are using this type of WC? How am I going to add the group valve to control the water if there's a break or there's a leak? How are you going to manage? Right? Yeah. Okay. So simply just get them connected. So this is quite straightforward. I don't want you to do something like this. I know that this one here, they have something called select, then what? You see this? Connect into, easy, right? But sometimes they can give you correctly. Sometimes they'll give you some funny shape come out. If they show this, I accept. But also make sure that the piping is correct. Copper A. If you come out PVC, you notice how come this pipe is thicker than this pipe? Then please change. Okay. Yesterday I was trying on 2022. I do this way, this pipe come like a snake. So I say, huh? How come like that? No. I manual draw myself, no choice. But luckily enough, my 2020 gave me a correct connection. So I'm happy. Okay. Now the urina, because you can see that from the urina, let me align this out first to the urina. So align AL. You notice that from the urina side, this valve, we look at the section BB, this is outside, look at it. So that means this is the old-fashioned valve, not like Singapore. Now this toilet is almost all auto sensor, right? Because of pandemic, COVID. If not, the older days, you got to press, right? Then the valve will spring back. Okay. You press, you spring back. That means they must have a pipe connecting here. Turn inside, join here. It cannot be connected too long because people keep pressing. You weaken the structure. The pipe will be bent. Okay, so this part here to draw, select this, point right click, draw pipes, make sure copper. If not, you may want to change this to stainless steel. Stainless steel is still tougher. Copper, you keep pressing, you'll bend later. All right, so in this case, I might change this to a different one. So pipe, I'll create a stainless steel for this particular use because it's exposed. People like to press. Edit type, duplicate, cold water. This one is your stainless steel. Okay. Then I'll edit here, change the material here to stainless steel. Now, what type of grade? I don't care yet. Let's say kiasu a bit, make the 10S thicker, means better, more costly. Be okay. Apply. Now stainless steel, you may want to draw from here. 25. Double check the material correct or not. Okay, domestic cold water, 25. It looks kind of thick. Okay, never mind. Draw longer first. Drag inside. Then you join here. Okay. So you see the connection slightly a bit different, stainless steel material. Look at the 3D. It looks kind of fatter compared to this. Copper slightly thinner. This guy a lot more thicker. See that? And normally the joint, this is not correct joint. This is more like a welding joint. Yeah, it's supposed to be what? Coupling one. So this one you want to change if you can install the or configure the stainless steel fitting. Then you see all the component look like this. Yeah, it should be something like this. Okay, he just said now we didn't do a proper adjustment. Okay, finally, I think time's almost up already. At our side view here, BB, I'm going to add a valve. Now this valve, where can I get the valve? You go to pipe accessories. Default is not loaded. You go to yes to load one. It's under pipe valve. That means all the way, it's just the same as your those pipe fitting component. Under pipes, look for a valve. Then there's so many valves. Now, normally when you use, supposed to be a globe valve All right, but normally it's a spring because you press, the spring will push back but I don't have any spring here. And this one here they create is only so far what I know is only for model, because when you look at, let's say, the gate valve, the size pipe is 50. What is our pipe size here? 25. So this gate valve cannot use one. Here, if I choose my globe valve, see, I have 10 to 50. Although threaded is wrong. Threaded means what? You could turn ma. So here, I will not talk about the accuracy, whether this is whatever valve. As long as size concern, we can use. I'm happy with it. Because this library doesn't come with a standard component for this particular usage. Yeah. Okay. So I'll select the valve that can give me the size. That's what I want. Open. Sorry, select first. Open. You load it in, choose the correct size, which is 25, and you insert it in. Insert. Then you do the rotation. Oops, wrong side. Okay, one more. Done already. And this guy look like that. So funny, yeah. Okay, normally there's supposed to screw nuts lah, but I don't know why the design here stainless steel doesn't provide lah. So make full use of it lah. Don't have, never mind. Then I'll lower my pipe. Now, normally for them to press a button, this is more on the screw winding type. I want you guys to learn how to modify this, become a press type. Okay, I'm going to select this valve and I'm going to edit the family again. Okay, come to here. Under the views, look at the elevation. Let's say this one should be okay. Look at the plan first. Plan. Can't tell, terrible. Okay, never mind. Let's say look from the left. Can see not? Left means on top lah. Okay, top. This is the thickness, but this is controlled by, there's a dimension which you might not see here. Here don't show, fine. Go to the right, then so left, then go to the right. It should have some value to show it to you. It don't have a weird. Front. It's under front. See? So you can see what is the actual height if you need to change. The wheel thickness normally is not 6 mm. For press button, normally slightly thicker. It could be 10 to 15 because it's a cap on. So this detail I don't want to change. I just want you to change is this length here, which is more important. So this length and this controlled together is what we call your overall height. So I need to change this. How to change? Let's close first. No need to save. Because when you select this valve, you go to your edit type. You should see the information from here. There is something called, see, overall height. See now, so here, change to 50, see works or not. See, you can press, but 50 a bit too short lah. Let's say give around 60. Apply. That's good. Enough already. But not that how 200 plus. 60 to 65 at least I would say reasonable. You see, do model, we also must think of the proportional, the view, the model itself. Okay, if okay, then I think I'll stop here lah. So the rest I leave it to you guys to finish all your cold water. Hot water, not sure, no worries. I will show you guys on next lesson. Okay, yeah, so if you take a look at the 3D, you should slowly, this one should be the same, and this one here, how you're going to connect. That will be challenging. Okay, everyone okay now? If not, hold on first. Let me capture your screenshot before you guys can go off. And remember, if you're going off, remember to sign out. So screen A. Okay, ready? Yep. That is your attendance. Okay, file save as attendance at 12:17. 17. Okay, questions?
My name,
Sorry, now fine.
I mean, you screenshot, but my name never, cannot see.
Your name cannot see. How come? I missed out. Let me
I
check.
think my name is right below.
Let me check. Let me check. If it's not inside, it's a bit weird. It should not be. Say cannot see. Can what? What cannot see?
Oh, sorry, I think it's my screen.
It's your screen, is it? Not my screen. My screen cannot see Jalat already.
Sorry.
Okay, no problem. Okay, he's there lah. No worries. Okay, so I save my file first. Okay, so you guys go and finish until the other few more lah for the cold water. Then next lesson I'll show on the hot water. Yeah, then maybe partial of it if it's done, hot water done, then we'll do your fire. Yeah. Then you can if finish early, then we'll do all your documentation. Or if not, any open question, please highlight to me. Any questions? If no, then I'll just stop here and you guys just check out. Yeah. Okay, that's it. Good day. 2 more lessons before New Year. All right. Is it 24 and 31st? Yeah. Okay. Bye-bye, guys.
Goodbye, sir.
Bye-bye. Remember to check out, sign out first before you go.
Fine, sir.
Bye-bye.